During the last class, we were discussing about structures, and we have seen how structures can be defined and how structures can be used. That is, how to store data into structures, how the data from the structures can be retrieved. And we saw a problem in which we used structures to display the content of that particular structure also. Input data into structure as well as display content of the structure. Now what we discuss is about array of structures. The most efficient or the most important property of a structure is that we can create an array of structures. If we use only structures and if the structures cannot be made into an array, it is of no use, almost of no use actually. But when we can create an array of structures, it is very easy for us to store a lot of data like in the case of a student's data, like we want to store the data of students in a class. So in a class we know that there are some around 60 students are there. So if all the data related to a particular student is to be stored, either we have to create 60 different structure variables in order to store the data of all the 60 students, but it will be easy if we can create an array of structures and using the index of that particular array we can access each element in that particular array. So each element in that array is a structure, and each structure constitutes of a number of different items or different fields in it. So the best thing with the structures is that we can create arrays of structures. So we know that an array can be defined to include the structure type variables also. That is, the array, we know that it is the same type of data is being stored inside that particular array. If there are 10 elements in an array, all the 10 elements should be of the same type. But in a structure, you know that the different data types can be stored inside a structure. So using an array of structures, you can store different data types in an array, almost different data types in an array, but it will be in a structure format. That is, each element will be a structure. So this array of structures can hold a number of records corresponding to the structure variable. And to declare an array of structures, first we have to define a structure type and then declare an array variable of that type. So you know how to declare a structure type. In the case of declaring a structure type, you have to give the tag name also. Then only we can define it as a particular type of structure type. If you doesn't give a particular tag name, then it may be difficult for you to create an array of structures. Still it is possible, but then the definition will be somewhat ambiguous in the sense for a person who reads that particular program, he may not be able to understand it easily. So the array of structures is defined in the second way of declaring the structures that we have seen. That is, we use a tag name along with the structure definition, and then using that particular tag name we declare the structure array or the array of structures. So let's see an example in which we write a C program to input details like roll number, name, and marks of 3 subjects also. So that is roll number is there, name is there, as well as marks of 3 different subjects will be there related to n students, and to sort the details in the descending order of total marks with a suitable output. So this is what we are going to do. We have n number of students, and for each student there are the details like roll number, name, and marks of 3 subjects. And obviously, since we have to sort the details in the descending order of the total marks, there should be a field for storing the total marks also. So there will be roll number, name, marks of 3 subjects, and then the total marks field also. So we have to input this many number of students or this many data into that particular program, and then the program has to calculate the total marks of each of the students, and then output the details in such a way that the maximum marks, the maximum total marks should come at the top and the lowest total marks should come at the bottom. So let's see how this can be done. Okay. So here is the program. Obviously we start with hash include stdio.h and then hash include conio.h. Then we define the structure variable. The structure type is being defined. struct, the struct, the keyword struct, then stud is the structure type that we are defining in this particular case, stud. So that is the strut. So that is the structure type that we define for storing the details of a particular student. Then we start the double braces, or open the double braces. Then within the double braces we use the variables like int roll number. So the roll number will be an integer value. Then the name should always be a character array. So char name, then 25 is the maximum size of the name, that the string, the maximum size of the string that can be used as a name. Then int mark 3. So here we are using 3 because we want to store data of or marks of 3 different subjects. So actually what this particular definition creates is, it is an array of integer values. So each integer value will represent a particular mark or mark for a particular subject. Then finally there is int total. This total mark is the total field that will store the total marks for that particular student. So then the closing braces, then semicolon. So this is the structure definition. So the structure is defined as stud, and it has 4 different fields in it: roll number, name, mark, as well as total. And in mark there it is an array, and it is an array of size 3. So that is 3 spaces or 3 values can be stored in that particular array. Sorry. So then we start void main. So it can be int main void, or void main, or void main void, etc., etc. So that can be many different types, no problem. So then we start again the double braces for the main function. Then struct student 50. So this is the definition for the array of structures. You know that this particular stud, it is an array. I mean, it is a structure. Stud, that is a structure. So it is defined here. Then here in this particular line, what we actually define is, we define a variable or an array of size 50. So the name of that particular array is student. So student is the array, and it can contain a maximum of 50 elements or 50 details of 50 people or 50 students. Then the definition is like this: struct, struct, because we are creating an array of structures, the data type should be a structure. That is why we use the keyword struct in front of that particular definition. So struct, then what type of structure it is? It is a structure of type stud. So the stud type data or stud type structure is being used here, and then we created variable or an array. The variable name or the array name is student, and the size of that particular array is 50. So this is how we define an array of type stud, and the number of elements that can be stored in that particular array is 50. So then we create another variable known as temp, and the temp variable, it is also of the type stud. This particular variable is used in order to swap two different students or student data if we want to swap two different students data in order to sort it. We want to sort the particular data based on the total number of total marks. So if we want to swap the values of or the details of two different students, so in that case you have to use a third variable, and that particular third variable is this temp. So struct std temp. So in this case the temp variable, it is just a structure. It is not an array of structures, it is just a structure itself. Then we use some counters as well as some other variables that is required for the proper execution of the program. So int I, j, then max, p, n, etc. So then we put, that is we display how many students, that should be less than or equal to 50. So the maximum size of the student array is 50. So we can store a maximum of 50 students in that particular array. So we display the message, that is how many students are there. So first we have to input, we have to take in how many students or data of how many students will be entered in this particular case. So in that case we scanf percentage d ampersand n. So ampersand n is for n represents the number of students or the number of data in the student array. So scanf percentage d and ampersand n. So since n is an integer value, we use percentage d as the type specifier. So then for I equal to 0, I less than n, I plus plus. So in this case I is used as the counter and n is the total number of students, and for each student we have to enter the roll number as well as name. Then the roll number as well as name will be read into that particular data. So puts enter roll number and name, so it will display the message, that is enter roll number as well as name. And then the scanf. In the scanf we are scanning the roll number as well as name together. So percentage d, percentage s. Percentage d is for the integer roll number and percentage s is for the character array or the string name. So then it is being read as ampersand student I dot roll number comma student I dot name. So if I is equal to 0, when I is equal to 0, the data that is entered, the value of the roll number as well as the name will go to the 0th element in that particular array, that is the first position, into the first position. Then the student I dot total, it is initialized as 0. That we will be calculating along with the entering the data for the three subjects, the marks for the three subjects. So then for puts enter marks for three subjects, that is the message will be displayed on screen, that is we have to enter the marks of three subjects. Then we use another for loop in order to scan the marks. Here the for loop is used since we have to input 3 marks for the subjects. For the 3 different variables are to be, or 3 different values are to be read from the user input, and those values that is being read from the screen or from the user input device, that is to be stored for that particular student. So in that case the scanf value, that is for j equal to 0, j less than 3. So since there are 3 different subjects, we use for 0, 1 and 2. So that is j equal to 0 and j less than 3. Then j plus plus scanf percentage d ampersand student I dot mark j. So that is that all the marks student I that will remain same if it is the 0th student, then student 0. Then mark value, this j will vary from 0 to 2, 0, 1 and 2. So for the first mark, so the first mark will be go to the mark 0, then the second mark 1, then the third mark 2. So all the marks will be stored in the corresponding mark variable or the mark array. Then student I dot total plus equal to student I dot mark j. We are initializing student I dot total as 0 because if there are some junk values, maybe while creating that particular or while allocating the memory location for or reserving the memory location for that particular variable, it is possible that some junk characters are already or some junk values are already there in that particular memory location. So if we doesn't initialize that particular total value to 0, there is a chance that the total value, the value of the total at the end of the calculation may be different from the actual marks. So that is why we go for some initialization as 0. That is a must. That is a must while we are declaring some variables and we want to input or we want to add some particular value into that particular variable. Then obviously initially you have to give it a value of 0. Otherwise, if you avoid this initialization to 0, probably there is a chance, it is not always necessary, but there is a chance that it will be giving you an error or will be giving you some error values. So we initialize it to 0. So during the scanning of the marks, each mark is added to the total, and thus after entering the third mark, we will be getting the total as the total of all the 3 marks. Then we go for the sorting. So by this line we have completed entering the data as well as calculating the total of total marks for that particular student. Then we go to the sorting part. For sorting, what we have to do is we have to check whether the total mark is to be at the topmost position. The total marks should be, the maximum marks should be at the topmost position, and the next top value should be in the next position, etc., etc. So what we initially does is for j equal to 0, j less than n minus 1, j plus plus 1. So we are searching from j equal to 0 to j equal to n minus 1. We are not searching j equal to n because the maximum value for n is if the maximum value for n is 50. Suppose we have entered n as 5. So the indexes will vary from 0, 1, 2, 3 and 4. So that is the up to 4 it will be 5 elements. So what we have to search is we have to search up to 3 only, because we are comparing 3 with 4, and if 4 is larger then it is being swapped. So let's see how the particular sorting is being done. So then first we initialize max, the value max as initialized, it is an integer value. It is initialized as student j dot total. Suppose we are considering the first student, so it will be student 0 dot total. Then we assume that p equal to j, p is taken as j. So then temp equal to student j, temp is initialized with the student j. Now for I equal to j plus 1, I less than or equal to n minus 1. So up to the last one, that is if we have started with j equal to 0, so I starts with j plus 1, so the next element. So I should be starting with 1 in this case, and I should be going up to n minus 1. If n is 5, it should go up to 4. So the last element, up to the last element. So then we are checking if student I dot total is greater than max. That is, if this particular max value, that is student j dot total value is greater than student I dot total, so in that case we have to swap it. We are swapping the max with the corresponding student. So the maximum will be, we will be storing the maximum value. The maximum value will be considered in this particular case from 0 to n minus 1, that is 0 to 4. All the positions, the maximum value we will be finding out. So that is the max will be student I dot total, and in that case P is taken as I. So the index of that particular maximum value will be stored in P. So now temp equal to student I. So that initially it was student J, now it is student I has become the temp value. So this goes on till the last one, and thus the maximum value we will be finding out. And then finally the student P will be equal to student J, and student J will be temp. So student P means the maximum value. P will be getting the index of P will be getting the index of the maximum value, the maximum total. P will be getting the index of the maximum total, and that value, the maximum as well as the current value, the current student. So that is being swapped. So then the student J is temp. So that is what is happening. So like this it goes on, and then when J becomes 1. So now what happens is, in the initial position the maximum has came up, the maximum value of the student, that is in the initial position. So now the next value is being taken, J equal to 1. So then from 1 to n minus 1, that is 1 to 4, which is the maximum value, that is we are finding out. So that will be placed in the second position. So likewise it goes on, and it goes on until the entire thing is being sorted. So then finally we output the sorted list. In order to output the sorted list, we initially print or display a message, that is the sorted list. Then for I equal to 0, I less than n. So I is less than n means up to n minus 1. So then I plus plus, then we print /n, that is for the new line, then percentage 5d, so that is for roll number we are reserving 5 spaces, percentage 12s for the name we are reserving 12 spaces, percentage 3d for the first mark, so the mark 0, so we are reserving 3 spaces, marks 2, I mean mark 1, the next position, so that is again 3 positions, 3 spaces. Then for the last mark also it is 3 spaces, and for the total mark we are reserving 4 spaces. So then student I dot roll number, student I dot name, student I dot mark 0, because the mark is an array, it is an array of size 3. All the marks are to be input in as different elements. So that is why mark 0, then student I dot mark 1, student I dot mark 2, then finally student I dot total. Then finally a get ch. Get ch, as you know, the completion, the execution of the program will be completed only when we will be we input some specific or any keyboard character. Any keyboard character is enough. So let us try it out. So there is no errors in it. So no error. So I am running it. How many students? I will be taking only 4 students. So more than that it will be difficult. So enter the roll number and name. I am entering the roll number as 1 and name as say A, B, C, D, E. Then enter the marks for 3 subjects. Say the total marks is out of 20. So I am entering some marks as 12, then 15, 18. So 3 marks entered. So then for the next student, enter the roll number and name. Say the roll number is 2, and the name is also I have to enter. Name is HGJIK. So whatever it is, some name. So then enter the marks of 3 subjects. So it is say 10, 18 and 13. So enter again roll number and name. So the third student, roll number and the name is XYZ. So enter the marks of 3 subjects. Say it is 16, 19 and 20. So 3 marks. So again the fourth student, enter the roll number and name. The fourth student, so I am entering the roll number as 4. So the name is say MNOP. So enter the marks for 3 subjects again. So say 9, 17, 15. So this is the total marks. So now the total mark sorted list. So the first student is 3. It is XYZ. The C 3 XYZ. The total marks is 16, 19 and 20. The total is 55. See, if you add it, 20 plus 19, 39 plus 6, 45 plus 10, 55. So that is the total maximum marks. So then the next comes 1. 1 is it has A, B, C, D, E. So that is 12, 15 and 18. So the total marks is only 45. The third is 2, H, G, J, I, K, some name. So it is 10, 18 and 13. It is 41, and the last one, fourth one, is also MNOP. So it is also 41. So because these two are of same marks, it comes in that same order itself, because it doesn't changes its order. So that is why it is 2 and 4 are coming in the same, having the same marks, and they are same total marks, and they are in the same order itself. So this is how an array of structures is being used. So by now you have found out how an array of structures can be used in practice. So now how to pass a structure to functions. In order to pass a structure to functions, you know that the functions require parameters. Many functions require parameters, and in many cases the structures, the data from the structures will have to be passed to the functions in order to perform some specific operations. So in that case, the structure variable can be passed to a function in 3 different methods. There are 3 different methods of passing a structure variable to a function, and one of them is very elementary method, that is the individual elements of a structures can be passed to the functions as actual arguments. That is in the case of our student record, student 1 dot roll number, that is an individual element of that particular structure. Student dot roll number, so that is an element. That type of variables, or that variables can be passed into the functions as actual arguments. So individual elements in a structure is passed to the functions as actual arguments. That is the normal method that we used when we are passing common variables, our usual variables, into a function. Then there is another possibility, that is the entire structure can be passed to the function by passing a copy to the function. As we pass our data into a function, a structure variable can also be passed into the function. So that is, the entire structure is being passed. In the first case, we are passing only individual elements of the structure. In this method, in the second method, we are passing the entire structure into the function. And then the final method is the concept of pointers. In the case of concept of pointers, actually we are not passing the entire structure into into the new function, but instead we will be passing the memory location where that particular structure is being stored. So that way we are not creating a copy of the original structure. So in the second method, we are creating a copy of the structure, and thus whatever changes we make inside the function won't reflect inside our main function. But in the case of passing using the pointers, if we are using the pointers, then whatever changes that we make within that particular function, or for that particular structure within the function, will be reflected outside that function also. So that is the difference between passing a copy as well as passing by pointers. So passing a structure to the functions, an example is here we are having a particular structure, that is struct book. Book is the name of the structure, and it has three different members: int number, the number of the particular book, then char title 30, a string of title, string for title, then another string for author. So char author 20. Then void main struct book b1 and struct book process. See the function prototype for the structure type. So for the structure type function prototype, so here it is to be declared as struct. So the value that is being returned by the process, the function process, is struct itself. Then book, the book is the struct type. Then process, the process is the function name. Struct book process, and then the double quotes, I mean the brackets. Then b1 equal to process b1. So what some process is to be done. So b1 equal to process b1. We are calling this particular function process with that particular structure type, that is a variable of type structure book b1. Then the function of type struct, the function which returns the data type struct as well as which it takes in the data type struct, is given here. Struct book process struct p. So p is the element that is being passed into this particular structure. So there are some operations being carried out, we don't know what is it, but still the final things, that is p dot number is equal to 10, we are changing whatever be the structure that is coming up, for that one the number is being changed to 10. Then strcpy p dot title, the title of that particular element or that particular structure will be changed to PIC. Then we are returning that particular p, that particular structure. So that is how a structure can be passed into a function, as well as a structure can be returned from the function. So this is the direct method of passing a structure to functions, by creating a copy of that particular structure for the function to work with. And how to pass a structure using the pointers, that we will study in the next module. So while we are studying about the pointers, that method we will study. And then how there is a unary operator size of, that you have already studied. The size of operator will give you the memory space that is occupied by that particular variable. So if you give an integer variable into size, the size of may return 2 or 4 depending on the type of machine that you are using. So the size of operator, it is a unary operator. It is used to return the number of bytes needed in the memory to store a particular variable. So this particular size of operator can be used to evaluate the number of bytes that is required for storing a structure also. Hold the members of a structure. So when used with an array variable, it would give the total number of bytes and the array needs. So the size of operator, if it is used with a structure, that is size of say stud, so in that case it will return the total number of bytes that is required to hold all the elements or all the members in that particular structure. If you consider an array of structures, the size of operator will give you the total amount of memory that is required to store all the elements within that array along with all the members. So that is, if an array, if a structure consists of say an integer value and a character array of size 20. So for the character array of size 20, we require at least 20 spaces, 20 bytes, and then for the memory, this integer value, we need another 4 bytes. So a total of 24 bytes is required for a variable of that particular structure to be stored. So if we create an array of that particular structure, then if there are some say 10 members in that array, so 10 into 24, that is 240 will be the value or the total number of space, the memory space required in terms of bytes to store all the elements in the array of that particular structure. So the size of operator will give you the value as 240. So that is how the size of is being used inside structures. And with that one we end today's session, and we will continue with a new topic in the next class. It is about union. Union is almost similar to structures, but with some differences. So we will discuss about it in the next class.